So this is 3.41, controlling chemical reactions. So the first kind of thing, this is really nice and easy, it's just to get you started to understand different properties. So which one does it represent, a solid, liquid or gas? This one here, definite shape, have high densities. That is a solid. State of mass has low density, flows easily, no definite volume is gas. Materials in the state flow easily, they definite volume and hard to compress, that is liquids. Okay. So then I drew some diagrams of what each one looks like, and then there was some information to fill out. So particles are arranged in lines, bonded together. We say solids are strong, they have a regular shape, and they only vibrate. Liquids have more space, so they move around more quickly and in all directions. They have no volume. Gases are even more free and will move out to fill a container because they are less dense. Describe what happens when it goes from a liquid to a gas. It evaporates, but all the bonds break, so it's free to move. What happens when you freeze it? Bonds become firmer, solid structures form, and it is freezing. Next one then, looking at endothermic and exothermic. So the first question here asks you to say whether it was exothermic or endothermic. It's endothermic because the products are higher up. Label, reactants, products, activation energy, and delta H. Okay, activation energy always goes from reactants to the top of the hump. Determine the delta H, so that's reactants minus products. So, okay, and then activation energy is the difference from the top to the reactants, that would be 200. How much energy released or absorbed? 50. How much energy is required for the reaction to occur? 200, okay, because that's because reaction to occur will be activation energy, energy absorbed is delta H, okay. This is an endothermic again. Explain how the reactants below products more energy required to break and form new products. What is meant by the term activation energy? Minimum amount of energy required for a reaction to occur. Next one then is looking at some rates questions. First bit, balance symbol equation. There was 1 mark for everyone putting the symbol for water, which is H2O there. Then the second mark would have been the 2. If in doubt, put a 2 in the box, okay? The reaction is very slow at room temperature. The student suggests that you can increase by adding a catalyst. State other ways in which the rate of reaction could be increased. He could increase the temperature. Okay. Use the results to describe the effect of change in the temperature. Temperature decreases the time taken for the calcium to disappear. Name a factor that could be changed in the experiments between 1 and 2 and describe the effect this has on reaction time. So surface area decreases reaction time. Other things that need to be kept the same: concentration of acid, volume of acid. A very similar experiment then, this time with looking at the colour change. State 2 variables that need to be controlled: volume of acid and concentration of acid. State 1 reason why these variables need to be controlled: accuracy, fair test, precision of results. Okay. State the conclusions that can be made from the results: higher the volume of thiosulfate, the quicker the rate of reaction. Explain the results in terms of particles: more particles which can react, more chance of collisions, more chance of successful collisions. This was then looking at tangents and stuff like this. It doesn't come up often, but it could, so nice to have found a question that you can do. Why is it stopped at 4 minutes? It's because all the reactants have been used up, so the reaction is no longer progressing, okay? Calculate rate. The first thing you need to do is draw your tangent, okay? And then I did the difference in y over the difference in x. So x is easy to work out. So I did 2 numbers that are equal values from 2. So I did 3 and 1. Okay, then I looked at the value that corresponds to 1 on the y-axis, which would be 46, and the value that corresponds to 3 on the y-axis. Okay, took them away from each other. I ended up with 40 over 2. It's not always going to be that nice a number, and then I divided that, which would give me 20. Okay, as the reaction proceeds, it's predicted the mass of the products collected each minute is half the previous minute. Explain whether the graph supports this prediction. So at 1 minute it's 46, at 2 minutes it's 70, at 3 minutes it's 82. So that's 24. The difference between that is 12, sorry. The next one then would be 6. So as the minutes go up, the mass collected is half the original mass in terms of the difference in mass. Okay, it's not actually in terms of the collection of mass. Okay. Catalysts then. Explain what a catalyst is. It lowers activation energy without being used up, increases the rate. Give 2 reasons why it's important to develop effective catalysts. It increases the yield and decreases the time for reaction. State the dependent variable is the height of the foam. 2 variables that need to be kept the same: temperature, solution, volume of catalyst. Explain why the catalyst is most effective. That would be magnesium oxide, the largest volume of foam produced. State one inaccuracy in the experiment and how it can be improved, measuring the height of foam using a higher resolution ruler. Next one then, plotting a graph, okay, which is this light pink line here. 3 marks for that. I wouldn't say my curve's the best, okay, but I am doing it on the iPad, so bear with. At what time is the reaction complete? Is when it starts to level off. So on this one, it would be 50. Add another line at 40. So this was done at 30, so I added another line, which would go up to 40. In terms of particles, how the rate of reaction changes when a higher concentration is used. Increased rates means there's more particles in a higher concentration in the same volume. Same volume, increased chance of collisions. Describe what's meant by thermal runaway, an uncontrolled reaction of exothermic reaction. Heat does not escape the reaction, so carries on increasing the rate. That should be carries like that. One way of a thermal reaction can be prevented, ensuring heat is released from the reaction, so letting the heat out. State A is a thermal runaway, state another one. Now this was a really tricky question. It is D because that temperature is increasing, okay? That's a T decrease and that's a decrease, okay? So that's a bit of a tricky question. State how you determine this. Exothermic, temperature increase. Reaction A is exothermic because the energy required to break the bond is more than the energy released forming the bonds.